Hitesh Singla. In this series, we are covering UPSC Prelims CSAT 2023 paper. This is the 8th lecture of the series. In the previous 7 lectures, we have discussed till question number 74. Today, we will start with question number 75. It will be the last lecture of the series. So please do watch it and share it with your friends. So question number 75 says, how many natural numbers are there which gives a remainder of 31 when 1186 is divided by this natural number? So it is saying we have to find natural number n such that 1186 minus 31, which is nothing but 1155, is divided by n. And one more thing, n should be strictly greater than 31, because then only when n divides 1186, it will give a remainder. It might give a remainder 31. Fine. So we have to find all those n which divides 1155. Fine. And n is greater than 31. So 1155 is equal to 3 into 5 into 7 into 11. Okay. The prime factorization for 1155 is 3 into 5 into 7 into 11. So the possible divisor of 1155 are 1, 3, 5, 7, 11, then 15, 21, 33, 1, 3, 5, 7, 11, 15, 21, 33, 35, 55, 77, then 15 into 7, it is 105, 15 into 11 is 165, then 77 into 5, it is 77, 7 into 5, 7, 5, 35, 7, 5, 385. So 385 and 1155. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, one more is left. 2, 4, 6, 8, 10, 12, 14, 15. So which is left? 1 is there. 1, 3, 5, 7, 11, 3, 5, 15, 3, 7, 21, and 3, 11, 33. Yeah, and 3 into 7 into 11. So basically 21 into 11 to 10 and 231. 231. So you don't really need to find these number exactly. You just need to observe that 1 cannot be there, 3 cannot be there, 5, 7, 11, 15, 21. These all cannot be there. Only possibilities are left with 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 natural numbers. So correct option is option D. Let us see the question again. The question is asking, we have to find all those natural number n which when such that when 1186 is divided by n, it gives a remainder of 31. Fine. So first of all, we've found that all those natural number which divide 1186 minus 31, because if 1186 is congruent to 31 mod n, this implies n divides 1186 minus 31, which is equal to 1155. That we have discussed in our previous videos, this modulus term. In each video, in each previous lectures, we have discussed this term. A is congruent to B modulo n. So basically, we have to find the divisors of 1155. Also, since we want a remainder 31, so we need to know all those divisors which are greater than 31, because 11 is also a divisor of 1155, right? But when 1186 is divided by 11, the remainder cannot be 31. Fine, the remainder will be less than 11. So this is the reason we are finding all those natural number n which are dividing 1155 and which are strictly greater than 31. So first of all, we wrote the prime decomposition, prime factorization of 1155. It came out to be 3, 5, 7, 11. So there must be 16 divisors. I will share the trick if we have if we have the prime factorization of a number, then how to find the total number of divisors. Fine. So we will have 16 divisors. We have wrote down all the 16 divisors, and we have selected all those divisors which are strictly greater than 31, and we are through. Fine. Let us proceed to the next question. It is saying P, P, Q, Q, and R are be two-digit numbers. So P, P, Q, Q, R are two-digit numbers. So basically, one is less than equal to P, less than equal to 9, first of all. And similarly for Q and R. So let me write 1 less than equal to P, comma, Q, comma, R less than equal to 9. And P is given to be less than Q, less than R. If PP plus QQ plus RR is equal to TT0. So PP plus QQ plus RR is TT0. So you can write it as 11 times P plus Q plus R is equal to 110 times T, or P plus Q plus R is equal to 10T. 1 less than equal to P, comma Q, comma R, comma T less than equal to 9. All of these digits should be greater than equal to 1, less than equal to 9, and integers. Is a 3-digit number ending with 0. Consider the following statement. The number of possible values of P is 5. So how many possible values of P, Q, R, T can be there? So take T is equal to 1 first of all. So we need to find P plus Q plus R is equal to 10. So what are the possible choices? And keeping in mind, P is less than Q, less than R. So 127, 136, 145. 154 cannot be there, right? Because 5 will be less than 4. Then 2, 3, 5. This is one more choice. Then 2, 4 cannot be there because it will be 2, 4, 4, which cannot be true because P is strictly less than Q, less than R. Then 3, 4, and 3 should be there, but it is again not satisfying. P is less than Q, less than R. So 4 choices in this case when P is equal to 1. Then when P is equal to 2, so P plus Q plus R is equal to 20. So what are the possible choices again? 3, 8, and 9. Fine. Why 3, 8, 9? Because if I start with 2, then Q plus R must be 18, which is possible only when Q and R both are 9, which is not true. So 3, 8, 9. Then another choice is 4, 7, 9. Another choice is 5, then 7, 8, and 5, 6, 9. Fine. And if I start with 6, then it cannot be true because it should be 6, 7, 13, and the other one should be 7 because P plus Q plus R is equal to 20. So 4 choices here. Fine. These are the only 8 choices for P plus Q plus R is equal to 10T for certain numbers P, Q, R, and T. Also, if I take T is equal to 3, then P plus Q plus R is 30, which is not possible because all of these 3 digits are less than equal to 9. Fine. So we have only these 8 options. Now let us get into the question. The number of possible values of P is 5. So how many values of P are there? 1, 2, 3, 4, 5. It is correct. Number of possible values of P is 5. Number of possible value of Q is 6. So 1, 2, 3, 4, 5, 6, which is also true. Hence, both 1 and 2 are true. The question when it was, we have, in the first instance, the question was seems to be very complicated, but as soon as we just wrote the information, it is done. Fine. Let us proceed to the next question. What is the sum of all 4-digit number less than 2000 formed by the digit 1, 2, 3, and 4, where none of the digit is repeated? So we have these 4-digit number has to be less than 2000. So first digit is 1, compulsory, right? What are left? 2, 3, and 4, right? So 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, and 1, 4, 3, 2. These are the 6 numbers. You just need to add them and we are done, right? Or else, if we just add them directly, then it might take a lot of time. But if you just write it, it is 1 into 1000 plus 100 into 2 plus 10 into 3 plus 1 into 4. So 100 into 2 will come twice, 10 into 2 will come twice, and 1 into 2 will come twice. So 2 times 100 plus 2 times 10 plus 2 times 1. It will always come. Similarly, 2 times 100 plus 2 times 10 plus 2 times 1 into 3 will come here. Fine. Similarly, 2 times 100 plus 2 times 10 plus 2 times 1 times 4 will be there, and plus 6 times 1000. So if we add these 6 times 1000 plus 222 into 2 plus 3 plus 4, 6000 plus triple 2 into 9, 6000 plus 9 to the 9 twos are 18, 19, and 19. So basically 7998 is the correct answer. If we have added directly, then it might have taken a time for someone will take a more time in this calculation. It is up to you. You just need to add these 6 numbers, 6 4-digit numbers, and you are through. Fine. Let us proceed to the next question. What is the number of selections of 10 consecutive things out of 12 things in a circle taken in the clockwise direction? It is saying, what is the number of selection of 10 consecutive things out of 12 things in a circle in a clockwise direction? So if I start with this, so it is say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Fine. So it is asking what is the number of selection of 10 consecutive things. So 10 consecutive things, if you have started with 1, so first 10 consecutive things should be here. So it is one of the choice. Then we can start with 2. Then we can start with 3. Similarly 4. Similarly 5. So if I start with 4, say I started with 4. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be a choice because since we are in the circle, so we can start with any number. So basically 12 choices will be there. As simple. Because we have to choose the 10 consecutive things. If we have started with a number, then we have to start with, if we have fixed a number, then we have to choose 10 consecutive things. So if we have started 2, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have to choose up to 11. If we have started with 3, then 3 to 12. If we have started with 4, then 4 to 12 and 1. In this manner, you can start with any of the number. Fine. So total 12. let us proceed to the next question. If today is Sunday, then which day is it exactly on 10 to the power 10 day? So as of now, the question seems to be a little tricky, right? Because we don't can't really find for the second day or 10th day. It is asking for 10 to the power 10th day. So let us do this. If today is Sunday, say one is Sunday, then we know on the 8th day it is Sunday, right? Let we understand. On the 8th day it is, if on 1 it is Sunday, then on 8th day it is Sunday, and on 9th it is Monday, and on 10th it is Tuesday. Is it understandable? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So on 8th day it is Sunday, then Monday, then Tuesday. Is it making sense? Or what we can choose? Okay, let us see for the 100th day also. Then we will see a pattern for 10 to the power 10th day. So on 10th day it is Tuesday. Fine. Then we know 8th day it is Sunday, 15, 22. Can you see a pattern? It is plus 7 only. Then 29. Then we know 36, 43. Similarly, it is on 99th day it will be Sunday. Is it making sense? Because on 71st day it is Sunday, then 71st, then 78th, then 85, then 92, then 99. So on 99th day it is Sunday, and on 100th day it is Monday. So 10 square it is Monday. 10 to the power 1 it is Tuesday. So what pattern did we observe? 10 to the power 1 is nothing but 3 mod 7. And the day it came is 3 minus 2 plus, sorry, 10 mod 7 is 3. And on 10th day, the day came out to be Sunday plus 3 minus 1. 3 minus 1 is 2 more days. So it is Tuesday. If you have observed in this CSAT paper, if you are known to the A is congruent to B mod N, out of these 80 questions and say 50 questions of mathematics, you would have done at least 20 questions. If you just know division algorithm, A is congruent to B mod N. It is just about the observation. And now see it for 10 square. It is 100. 100 we know 2 modulo 7, because for 14 7 98, 14 7 are 98, so 2 mod 7. And the date came out to be Sunday plus 2 minus 1, which is Monday. Now we need to find 10 to the power 10. First of all, just find 10 to the power 10 mod 7. So we know 10 square. 10 cube will be, 10 square is 2. 10 cube will be what? 6 mod 7. 10 to the power 4 is 4 mod 7. We have 10 to the power 4. So 10 to the power 8 is 4 into 4, 16. 16 is nothing but 2 mod 7. And 10 to the power 10 is 10 to the power 8 into 10 to the power 2, which is 2 into 2 mod 7, which is 4 mod 7. So the day will be Sunday plus 4 minus 1, which is equal to Wednesday. Hence, correct option is option A. Fine. And why are we doing minus 1? Because see, on we are doing modulo, but on the 8th day it will be 0, right? So Sunday you have to take to be 0 when you are dealing with modulo terms. Then you can see, okay, Sunday is 0, Monday is 1, Tuesday is 2. Fine. So when it is coming out to be 3, then three numbers will be 0, 1, 2. Now the starting is counting from 0. Fine. Or you can just see 3 minus 1, you can do 3 minus 1 and add the number of days. So 3 minus 1 is 2, Sunday plus 2 days, Tuesday. Similarly, 2 minus 1 is 1, Sunday plus 2 days, Monday. Fine. Let us proceed to the next question, the last question of CSAT prelims. There are three traffic signals. Each signal changes color from green to red and then from red to green. Fine. The first signal takes 25 seconds. The second signal takes 39 seconds, and the third signal takes 60 seconds to change the color from green to red. The duration of green and red colors are same. So if it is taking signal 1 will take 25 seconds from green to red and 25 seconds from red to green. Similarly, signal 2 will take 39 seconds from green to red, then plus 39 seconds from red to green. So signal 1 takes 50 seconds to come back to red. Signal 2 takes 78 seconds and signal 3 takes 120 seconds. Fine. The duration for green and red colors are same. At 2 p.m. they together turn green. At 2 p.m. they together were green. Okay, we can write here green also. At what time will they change to green next simultaneously? We need to find after how many seconds they will simultaneously change from red to green. So basically we need to take the LCM of 50, 78 and 120. See, if I am saying signal 1 is taking 2 seconds and signal 2 is taking say 5 seconds, then after how many seconds both signal will turn to green simultaneously? Then obviously after 10 seconds. You need to understand why we are taking the LCM. Say signal 1 is taking 2 seconds. Fine. To turn to green. Okay, let us make it 4 and 6, then it will be easier. To turn to green. So basically 2 seconds from red, green, sorry, 2 seconds from green to red, and then 2 seconds from red to green. And say signal 2 is taking 6 seconds. So basically green to red 3 seconds and red to green again 3 seconds, right? So after 2 seconds it will change to red, it is already green. After 4 seconds it is changed to green but it is already red. Then after 6 seconds it will be changed to again what it is. Okay, after 2 seconds let us see, first is on red and second is on green. After 4 seconds first is on green, second is on red. After 3 seconds, okay, after 6 seconds, make it 6 seconds, first is on again red, second is on after 6 seconds green, then 8, first will be on green and second will be on green only, but they have not changed the signal simultaneously. The question is asking at what time will they change to green next simultaneously? It was already green, second was already green there, right? And it has changed to green. So after 10 seconds first will change to red and second will change to red, but at different level of course. But after 12 seconds first will change to green and second will also change to green. 12 is nothing but LCM of 4 and 6, right? So we need to just take the LCM of 50, 78 and 120. Now these numbers seems to be very difficult to take the LCM. So just do the prime factorization, it will be easy. 2 into 5 into 5, 78. 2 into 3 into 13, 120. 2 cross 2 cross 2 cross 3 cross 5. So these two will be here, then these two have to be there, then this 3 will be there, then this 5 will be there, then these left 5 and 13 will be there. So you just need to multiply these number and you are through. Fine. So correct, and it will come out to be, I think, we need to do the math here. So it is coming out to be 8 in multiply 8 multiply 3 multiply 25 and multiplied by 13. It is 7800 seconds. So 3600 seconds, 7200 seconds, it will be 2 hours. So 4 hours. So 2 hours and 600 seconds. 600 seconds is 10 minutes. So basically after 2 hours, 10 minutes. So basically it started at 2. So after 2 or 10 minutes means 4 or 10 minutes. Fine. So with this question, we have discussed all the mathematical reasoning questions which were asked in UPSC CSAT 2023. If you have watched all our lectures, you will see that the questions were not so difficult. It is just about, yes, I can say that the paper was lengthy, but you were not asked to solve all the questions. You were just need to solve around 40 questions and they were definitely doable. Fine. And then what we can take home with this series is, if we are aware of some of the formulas, say sum of first n natural numbers, sum of squares of first n natural numbers, these two things. Third, position of the English alphabets. And fourth, this condition A is congruent to B mod n. So if you are just aware of these four conditions, these four results, then also you would have been able to do maximum of the questions which were asked in respect of mathematical reasoning. So for further videos and further lectures, please subscribe to our channel. We will come out with more series and more lectures, and you can connect us on Telegram and ask your queries there, and you can search @maths with Singla on Telegram. And we will soon start with the core subjects now. So please do join our Telegram channel and subscribe to our YouTube channel. And thank you for watching.